name is TAK Mathews. I will talk about evacuation lifts from an NBC 2016 perspective. And NBC 2016, two things that have been clearly brought in, elaborated is on seismic and on evacuation lifts. Now, when I talk about evacuation lifts, I'll probably be spending more time clarifying what it is not rather than getting into the details of what it is. So I don't think anybody requires any clarification on this. Traditionally, it has always been that we should not use elevators in the case of fire. It's been a very classic thing, and even today, everywhere you go, you'll see this notice. In fact, it's considered as one of the biggest marketing success stories anywhere in the world. You ask anybody, they will know. Do not use elevators in the case of fire. However, when we go to 9/11, it's a known fact that over 3,000 people survived because they forgot about this marketing rule and they used the elevators to get out of the two towers. And in 16 minutes, 3,000 people managed to escape because they used the elevators. Since then, there has been a rethought, and that is when the occupant evacuation operation came into place. Just note this, occupant evacuation operation. It first came in the International Building Code, where they sort of says estates were installed in accordance with Section 308, passenger elevators for public use shall be permitted to be used for occupant self-evacuation. Again, the key is self-evacuation, which in turn is highlighted more in A17.1. But let me tell you, I have been in enough number of discussions on this, and there are still a lot of unresolved issues. So this is being presented. We ask a query, and they say, no, we still are working on it because there are issues. This is an electrical equipment which has got its own issues coming up. If you look at it from an EN perspective, it is EN 8176. And if you look at from my ISO perspective, it is 18870. It's all talking about evacuation. Let me clarify this. Now I'll need to turn around a little bit because I can't remember all the words myself. So a firefighting lift, what is normally referred to as a fire lift, is for firemen. The evacuation lift, on the other hand, is for occupants to self-evacuate in the golden period before the firemen reach the site. Now, if you look at it and you know the Bombay traffic, etc., if there's a fire, it can be half an hour, it can be 45 minutes, it can be 1 hour. And Dr. Rengdale keeps saying this again and again. He can't stress enough that owners, occupants need to be looking in terms of what to do and not just wait for the firemen to reach. Again, if you look at it, the firemen are expected to be experts, knowing what needs to be done with a fire lift. They know the precautions to be taken. On the other hand, when we talk about occupants, laymen, they are laymen. So they would not know what needs to be done to use a fire lift. They would not know what are the emergency situations. So you can immediately see both the differences. So in terms of requirements, it is expected that the firefighting lift will be in a protected hoistway. But if you look around the country, most buildings, the fireman's lift is not in a protected hoistway. One of the things that I do keep telling around when I talk about this situation everywhere is that if it is not in a fire protected hoistway, or in a fire protected lobby, probably better not to use the elevator. The first drop of water, and there's a possibility that the elevator will get killed. On the other hand, when you look at the evacuation elevator, it has to be definitely in a fire protected hoistway or lobby. If it is not in a fire protected lobby, it's definitely not an emergency evacuation lift. A doubt? Stop me in between if there's a clarification that you require. I don't have a problem with that. That is what I would say. But if you look at firemen's lifts around the country, more than 75% are in just an open lobby. I could spend another 1 hour talking about the issues involved, but I'll skip that today. The operation is controlled by the fireman operation. So there's a difference with the fireman operation and the evacuation elevator. The fireman operation, again, if you go to NBC, it is defined clearly what it is. On the other hand, if you look at the evacuation elevator, it doesn't operate as per the fireman operation. I'll quickly go through the fireman operation. You toggle the switch, the elevators come and park, and then it's available only from inside the car operation. The evacuation lift is, for all practical purposes, still automatic. Then along with it, you need to have remote monitoring because the laymen do not know what is happening. So if there's any sign of water penetrating into the hoistway, the elevator has to be shut down. If any of the lobbies look like that there is a problem, elevator needs to be shut down. There has to be announcement systems because you're telling the layman. And of course, there has to be a fire control center from where all this is controlled. So from an Indian perspective, we have got clause 7.2 of part 5A, section 5A of part 8, which defines the evacuation lift. So let me just once again go back. Our evacuation lift is for occupant self-evacuation. And that's a huge difference that we do not seem to have understood. Now, there's one more difference which I would need to clarify. We in the elevator industry, somewhere along the line, started referring to the fireman's lift and the fire lift. And there is a notion that means that the lift is fire resistant, which is not the case. So the key aspects again, it's something which is in addition to staircase. So just because you have an evacuation lift doesn't mean that your staircase can be eliminated. That's not the intention. This is significantly expected for a tall building. It's expected for disabled people who cannot climb down the stairs. In all this, we need to keep in mind the staircase might still be the fastest evacuation means. Because the lift has to come, you might be waiting and you might actually lose an opportunity. So it has to be a combination of the lifts and the staircase. Here again, I would like to pause. Most of our buildings as such don't have enough elevators. So if you're going to be waiting for a fire lift, an emergency evacuation lift, you might not get a lift at all. So do not wait for the emergency evacuation lift. If you have an opportunity of escaping via the staircase, please do that. Sorry, I think I'll have to shift around. Now, that's going to take more time. So when you look at the prerequisites, you need to have a facility for detecting fire, smoke, and temperature. Again, keep in mind what is the situation. Laymen are using the elevators. They are not in a position to check and verify whether the elevators can be used or not. You need to know the location of the event. So if suppose it is on the 4th floor, it's probably best not to use the evacuation lift to evacuate, let's say, from the 30th floor, because the 4th floor could turn out to be a problem. You need to have emergency power operations. Key aspects, the types of evacuation. Is it a fire-related evacuation? Is it some sort of a security evacuation? The situation will change. So if it's a fire situation, there's a possibility that there's risk to the elevator. On the other hand, if the risk is related to something like, let's say, a terrorist attack, probably you do not have as much risk as you have in a fire scenario. However, this is all to be monitored. That's where the announcement system comes into place. And once you have the incident, then the question comes up, are these lifts available for evacuation? Yes or no? Then again, the decision comes on as we go along, whether it's something that can continue to be used or not. I did mention the number and size of lifts. So if you are planning on evacuation using lifts, you need to have adequate lifts, you need to have adequate size. Now, if you look at the Burj Khalifa, for instance, it's something where the topmost floors are expected to be evacuated using only elevators. Remember what I said, as such, most of our buildings do not have enough elevators. So we do have a little bit of an issue over here. So if it is planned, it has to be very clear that you have adequate numbers. Another issue that you really need to be worried about is removal and suspension of the lift from evacuation service. So in the eventuality, the elevator has been compromised, the evacuation operation has to be suspended. Otherwise, we can have a situation where people are entrapped, or even worse, they get evacuated onto the floor with the incident. The car has to be constantly monitored. I remember what I said about water. Water penetrates into the hoistway, the chance that your elevator is already dead. Communication, constantly communication has to be available between the people who are in the elevator, the people who are waiting to be evacuated, and the fire center. So the question that comes up is, wouldn't firemen also require this? If you do get into the operation, there is an SOP for firemen. So you have actually somebody called a lift operator inside. Remember what I said, the elevators get operated only from inside the lift. He needs to open the door, and it's got a dead man switch. And in the eventuality that there's a problem, he takes the button, the elevator closes again. And these are people who are supposed to be experts. And there has to be somebody who takes a decision, when do we cancel the evacuation operation. We have NBC 2016, now we are into 2020. Granted that NBC 2016 was published only in 2017, but we still have a huge issue. First, there's a lack of understanding as to what an emergency evacuation lift is supposed to do. And beyond all that, we do not have buy-in from the fire authorities, we do not have buy-in from architects, we do not have buy-in from developers. In fact, in some cases, we do not even have buy-in from the elevator companies, from the elevator industry. And that puts us in a very difficult situation, because if you're going to be following two different rules, and I'll give one example. So if some of the people are going to be driving on the left side of the road and some people are going to be riding on the right side of the road, we have a potential issue. And today we are moving into that position very fast. And let me give you examples. This is a fire evacuation specification that has come up from somewhere in this country. It says you need to provide a glass vision panel for both doors of minimum, what are the size? And should have a fire rating. Two problems here. First of all, the car door cannot be fire rated. You cannot get fire resistance for the car door by virtue of its construction. In any case, it is superfluous. Because if you have a landing door that is fire rated and the car is going up and down, you do not need that fire resistance for the car door. But in even case it was possible, we are talking about a situation where you have 4-hour fire resistance. What are our structures fire rated for? 2 hours. So we are trying to protect something which really is superfluous. On the other hand, it's technically not possible. Then it talks about vision panel for both the doors. IS 14665 is very clear that vision panels shall not be provided on power operated doors. So straight away there's a requirement that's in violation of IS 14665. And invariably what happens, if you're allowed to compromise on one aspect, you can compromise on everything else, right? Remember what I said about the left side of the road and the right side of the road? That's what effectively will happen. Another example, it says the fire evacuation shall be provided on every mid-landing of one of the enclosed staircase. Enclosed staircase makes sense. However, if you look at NBC 2016 part 4, this is not from the elevator people. It says lifts shall not open in staircase. You see where the dichotomy is happening. You see how it is it's a mismatch and it is contradicting each other. I have about 30 other points like this, which either cannot be enforced or is in contradiction to what NBC asked for or what IS 14665 asked for. So that is where we stand today, and I would open up for questions.
And, like, as an architect, I would like to know that in a nutshell.
Let me start by saying what is common. If the fireman's lift needs to be effective, or the evacuation lift needs to be effective, it needs to be in a protected lobby. Okay, so that's the common thing. Now, I'll just elaborate a little bit why I'm saying protected lobby vis-a-vis the pressurization that invariably keeps happening. So most of the buildings, what will happen is you'll pressurize the hoistway and they leave the lobby aside. Now, from a human safety perspective, it is smoke, fire, water. From an elevator perspective, it is water, fire, and smoke is the last of the problems. So you need to have it protected in such a way that it is protected against fire, obviously, and you are protecting it from water ingress. Okay. So that is from the first perspective. Second is the using perspective. The fireman's lift is used by firemen who are expected to know the standard operating procedure. So what happens is you put in the fireman operation, you get the lift to the main floor, and then the lift is available for use only from inside the car. So typically what would happen is you press your call, the doors do not close till you have the door close button permanently pressed. Now you reach the floor, you have to keep it permanently pressed for the door to fully open. So in between, if you release it, the door will close again. Now, from an SOP perspective also, the firemen are not supposed to use the lift beyond, at least the maximum, the closest they can get to the affected floor is 2 floors. So if the fire is on the 6th floor, should they use the lift? The answer is no. If the fire is on the 40th floor, they can probably use it till the 37th or the 38th floor. Under no circumstances should they cross the fire floor. Under no circumstances should they go to the fire floor. The firemen know this. Do the users know it? No. So then the users, people who are occupants who are waiting to be evacuated need to be guided. So you need to have CCTVs which tells the fire control center that the fire is here. Can you use the lift? Yes, no. 2, is there ingress into the hoistway? Is there water ingress into the hoistway? The answer is yes. Can you use the elevators? The answer is no. Are people waiting at some lobby? Yes, no, the fine. So there has to be a control of how it is happening. You need to have constant announcements that are happening.
Thank you, sir.
Thank you.
This is more about operational guidelines that you were talking about. I am as an architect. My simple question is, so what I understand, like the boiling point is, I need to make an elevator and then I put a fire resistant core around it, probably with the stair, and that becomes a fire core. And that can actually work both as a fireman and the evacuation.
Absolutely. In fact,
so life is simple for me. I just provide sufficient fire cores.
No, if you look at NBC, it also says that a fireman lift can also double up as occupant evacuation lift. But the key is, from an architect, architect's perspective, if you do not design the lobby, there's nothing. You can specify anything you want after that, it's not going to work.
Yeah, I totally understand. I have got one more question. I don't know, it's not related to fire, but it's a severe problem we architects are facing about elevator today. Can I raise this? Okay.
Sure.
When I started practicing in 2001, there was Otis and Kone. We used to follow their manual book, which gives us the sizes of the lift based on their number of occupants. Then Schindler came in. During my first project, Schindler came in. They said, sir, our size is slightly different. Okay, fine. But now, Otis has like Amar and MRL version. Each has 5 series. Kone has probably 15 series. There is Schindler, there is Toshiba, there is Mitsubishi, there is Thompson. Each have like 5 to 10 series. Each have different lift sizes. And what do we do? Which one do we follow? And the problem is, practical problem is, lift vendor is finalized after the building is half constructed. And obviously, the client doesn't think about it. They go about and finalize a lift vendor and he comes, sir, mera liye to bana nahi hai lift. And
could I address that question?
Please,
I'm not one of the sponsors here, I'm not one of the brands here. You just opened up an awesome situation for me. Jokes apart, it is a problem. And we as elevator consultants who know the Schindlers and the Otises, and you name them, we know them, we also struggle with hoistway sizes. And we constantly have an effort that goes on in the office to figure out what are the hoistway sizes that we need to work with. And having said that, if there is a constraint, we know how to put our hands around and tell them, okay, please supply it in this hoistway size. It's not an easy job, but it's a thing. The arrangements vary. The arrangements, the way how they have the roping, the way they have, like say for the MRO you mentioned. Some of them have flat belts, some of them have ropes. Some of them have big machines, some of them have tall machines. And all of them are patented. So they can't even go into the common land.
So if you remember, there was a time when Nokia has 10 different models. Each had 10 different types of chargers. Samsung had 10 different chargers. You name the brands, each has their own different ranges and different charges. Today, all have same.
Apple.
Only 1 or 2.
Apple, they make my life miserable.
Oh, yes, exactly. Just one or, but anyway, it's 1 or 2 variations. Our lives is so much easier. So I think the lift manufacturers sometimes at some point of time need to sit together and think about this problem.
I do agree. In fact, when we were putting together the charts for NBC 2016, we really had a tough time getting all of them to come under the same roof. Any more questions?
This lift is operated at the time of fire only. So what about the maintenance? Like,
Please do not have an elevator which operates only during fire. Trust me, when you want it, it'll never work. It should be part of an elevator which is constantly used.
and where will be the lift machine room for this lift? Because CFO told us to have it at the ground only.
It's not possible. You can quote me in saying that, and he won't like me for having said this. The fact of the matter is, the taller the building, the more important it is to have the evacuation lift, right?
Yeah.
Taller the building, faster the elevator. Faster the elevator, it's impossible to have the machine below. We have had discussions on this. For instance, it is 7 bends of rope that you will need to have if you're going to have the machine below. Effectively, it is 6 stretches of rope.
Yeah, and there is
So if
no
you're
vendor available to do that at the ground floor. So
unfortunately, madam,
we are not getting.
Unfortunately,
NOC,
madam,
CFO
there are
NOC.
vendors who claim that they can meet it. Unfortunately, and I stand here as a person from the industry, and I say that if a vendor says that, he's lying. Sorry for putting it across that.
No, it's not the
bluntly.
vendor, but CFO NOC we get only if we provide it at the ground floor.
It's technically not possible. So if somebody says that they are meeting it, it is technically not possible. You know, it's one of those tick marks that you will know,
Yeah, but we are
knowing
not
that it's
getting
not being done.
CFO NOC.
Well, in fact, on this particular thing, in fact, just before the session, I had a discussion with some of my fellow members from the Fire and Security Association of India and said that we have a problem. You know, we are putting developers, we are putting architects in trouble because we as experts are not taking a stand on what is right and what is not wrong. And I fully understand what you are saying. I've been talking in a number of forums. Last year, February, March, I talked about the fallacy of what is happening. Technically, it's not possible.
Thank you.
We will probably need to move on, and I think we can address some of these things during the panel discussion that we are going to have now. Okay, before we jump into the panel discussion, let me just give you a little bit of a background. And the slide is from March 8, 2019. At last year's session, I was talking on this subject. And I'm going to use the same slides to establish the foundation for our panel discussion. So somebody was asking me before we started the panel discussion, you must have been working hard for the slides, for the presentation. So I had to tell him no. Because for all practical purposes, I've been using these slides for the last 10 to 15 years, more or less, other than for just changing the format and the font, things have been more or less the same. So let's just get into it. You know, people have always had tall ambitions, and this is some from Wikipedia that earlier there used to be no buildings taller than 6 floors. For the obvious reason, you can't climb stairs. And even if you did have 6 floors, it was the poorest section who used to be pushed to the top floor because nobody wanted to climb. And in 1853, the entire thing changed because Otis came out with a safe elevator. And since then, the skylines have changed. So effectively, we're talking about the lifeline to the building is the elevator. So after structure, because we need to have the building standing up, right? If the building doesn't stand up, there's no tall building. The next important thing to living tall is the elevator. But the reality is, in most buildings, even the toilets get more priority than the elevators. Now, if somebody in this group disputes it, we can have this debate. I'm telling you, we can have this debate for long. But this is my experience as an elevator person and now as a consultant. So this is one of the consequences of this. 2019 has been an exceptionally bad year for the elevator industry. We have had 28 reported fatalities on elevators and escalators in 2019. Now 28 is reported. You know our country. It's anybody's guess as to how many fatalities have happened but are not reported. Is it 1:1? Is it 1:2? It definitely is higher than this number. And we definitely do have a problem, and that is from where our panel discussion starts off. When I proposed this subject, I had opposition from many people saying that, no, you're being very nasty or big. But in my opinion, this is the reality. And I know as the moderator, I should be neutral. And after this point, I'll try to be as neutral as is practically possible. So what we will be doing through the course of it is we will break up this problem sentence into 6 distinctive questions. We have architects on board. We have project directors, civil people on the panel. We have an MEP consultant who is from the elevator industry, so he will be sort of the bridge between both the groups. And we have somebody from the elevator industry with us. But before we jump into this panel discussion, we will be short presentations from 3 of the gentlemen. And I would first request Mr. Amar Tendulkar, Sustainability at Mahindra Lifespace Developers Limited. Amar oversees design, ideation and implementation across Mahindra Lifespaces developments encompassing residential projects, integrated business cities and industrial clusters. Amar has over 24 years of professional experience in architectural and real estate development and has enabled the delivery of multiple projects across the various geographical locations. 2 of the projects that I'm proud to talk about as his projects is Altamont and 1973, super tall buildings. He's been deeply involved in it. Amar completed his bachelor's degree in architecture with the first rank in merit from the Shivaji University and later taken master's degree in urban design from CEPT, Ahmedabad. He has spent the founding years of his career working with Pulitzer award-winning architect and Padma Bhushan Balakrishnan Doshi. I think that itself is a credible foundation from where he comes. Amar Tendulkar is respected in the real estate industry as a thought leader and has been invited in various national and international forums as a speaker to share his knowledge and experience.
So I'm actually privileged to work with TAK, and there was a good synergy between us. And I mean, we often have said and exchanged our lot of debates, knowledge in terms of doing these high-rise buildings. In 1973, we worked even on Crescent Bay, and we worked on Altamonte. So you missed one building, TAK. Nevertheless, so what TAK has said, he said that yes, elevators are the lifeline. So I want to say, even going further, if I consider my body as a high-rise building, what is most important is the circulation of blood, which is the logistics, to keep us moving. So if we have to keep our building working, what is most important to have the movement of the people going up and down. So that is the role that elevators play in the building, which is as important as moving the blood circulated in the body. So I'm just going back. So TAK has started from the 1853. I'm going even before that, and I want to show, what is the kind of a history of the elevators. And I was trying to actually find out some appropriate images for the 3rd century BC in the Greece. Unfortunately, I did not find it. But yes, I found on the net, it's all Googled kind of a thing. I must be very honest with you. It's not that, but some of these things I have seen personally in this. So 3rd century BC, the first elevator was found. In the Roman Colosseum, I know for sure that 24 elevators, about 8 of those spaces, they are still intact. And this is what I have learned, that 200 slaves were there. So the dynasties of the kings, those were during those times, and the women, they used to transport them, to see the circus and all. So elevators history go back towards the Roman circus, Colosseum. You see that in every 3 days, elevators carry equivalent to the entire Earth's population. So imagine what world we are living today, TAK. So that's why the people like TAK are very important for all of us. America has currently 700,000 elevators. So if America has in 7 lakh elevators, 700,000 elevators, and if you say, rest of the worlds probably have about, let's say 14 lakhs. So total we have about 21 lakh elevators. And if you'll say about 20 people travel, at the single time. So imagine more than about 2.5 crores people at any given instant, at any second, they are into the elevator. So why the safety of the elevators is very important. There's another, the yellow one probably you are not seeing, but the elevator music, which we all find, it's a kind of very kind of charming for all of us, keeping our mood. But it was first founded, to keep people calm from the fear of that elevator movement when they enter inside the elevator. So it's a very interesting fact. Modern day, it's Otis. That's where that Otis legacy is. That is what it is. And any average person today, whether it's in urban area or it's in village, okay, where there are elevators, he takes about 4 trips in a day. That is, and last is actually the tip to all of you. When you go to the elevator, don't press that close button again and again. It's not going to make it more quick. So I'll just go to the next slide. So from the history, so this is some image which you'll see. These were the kind of some of the elevators in the 3rd century BC. So this is an illustration from some of the fossils those were found. This is the installation of the elevator. This is the elevator, and it's an inclined elevator for one of the first elevators which was getting installed in the Eiffel Tower. So this elevator, see, it's a elevator. It's a double-decker elevator. People are sitting there, and initially it was manually pulled, and then now the modern elevators are there. Those there on the electrical these things. And third is how the elevators have been used even to draw the water. So this is the image which I am showing. It's just more like a dumbwaiter to pull the water. But during our, if you'll see our forts, even if you go to Jodhpur and all, there are you'll find an elevators where people used to go along with those water barrels and carry the waters in the tanks, and that was through the rope system. So this is another way. So just goods logistics purpose, the how the elevators are used. This is the rising skyline of Mumbai, and this is one of my projects, which of course I am proud of, and where we have worked. And it's not only one project, but if you'll see, this skyline in Mumbai was not seen just 10 years before. So 10 years before, as TAK has also said, most of the buildings were about 24 meters, which is about a 7-story building. And now our sudden graduation or sudden rise has happened from 24 meters building to 300 meters buildings. And what has happened is, when we did that, the RCC technology, the structural engineering technology, all those things have gone the kind of a transformation. The elevators which have to come in that speed of the technology transformations, those, I mean, we are not kind of we could not match. And we had just a discussion that if you have to have that safety, security, technology aspects have to embedded into the common man, or into the common professionals among the uh, fraternity. Most important is to have the elevators manufacturing started happening in India. And no, I'm not saying about the elevators which are about 24 meters or 30 meters kind of a technology. The high-speed elevators, when will start manufacturing in India, I think that is the time that entire safety, security, technology, all those aspects will start getting embedded amongst the professionals. So few of the elevators we all know: passenger elevators, express elevators. I mean, we have installed 6 meter plus per meter second. Uh, then there are dumb waiters which are used in the hotels. There are those paternosters. Those are the revolving elevators. We have seen. I've seen some of those in the US. So if you are going in a building and if you have to access the multiple wings, so those are the elevators which are used. Belt elevators you must have seen in many industries. And then there is a twin elevator. So twin elevators have the double-decker elevators as well as the elevators. There are 2 elevators or 3 elevators. Those they move in one shaft. Only ThyssenKrupp has got this technology, and they say they have got the lesser number of accidents than the aeroplanes, which have got the least number of accidents in the logistics or in the movements. So this is the kind of a complete, I can say, the transformation that we have seen from 3rd century BC to Roman Colosseum to have the kind of a twin elevator. The advantage I feel that with these twin elevators is where the space constraint is there, the construction costs are rising high. So if we can have such a technology where there are more than one number of lifts getting into the shaft, probably I think it will have a lot of impact in terms of uh, saving the cost and making the buildings most efficient. So that's all. Thank you.
I would now invite Mr. Mukesh Jaitly to give us his thought on it before we start the panel discussion.
Good afternoon, everyone. Um, just before the start of this session, and we were just chatting, and Mr. Tak happened to mention that you represent a developer and a good developer, but we don't have a perspective from developers who are not so good. So be rest assured, for a comparison's sake, I would definitely take examples where how things go wrong and why Mr. Tak feels that elevators are an orphan child in this industry. I got few slides made hurriedly, but I'll just. When he said the elevators are often, I had a counter view. I said the lifts are the vital organ of a high-rise building, and in my view, they are not an orphan. Instead, I strongly feel that they manage a very vital functions of transporting people and material that they cannot be neglected by designers, which are architects and developers. In fact, for developers, given the scenario, lifts are the pets. Pets means favorite child, because we do get incentivized by getting free FSI. You know, every architect in this room would agree with that. That we try to take advantage of new rule of x and 2x of the lift depth, the hoist depth and the width of it, and get a free FSI in front of the pass in the passage and use that FSI, which is equivalent of 1.5 times of sellable area. So for us, that's a benefit, and there's a sketch which demonstrates that thing. This is, I guess, everybody knows there's various parameters for lifts, and during the discussion, we'll go through all these points also. That is speed versus flow of traffic, speed versus height of the building, idle waiting times on the floors. Come again? Yeah. And, as a developer, and why they try to cut corners is also the design element which goes with the aesthetics and everything. It's something like somebody was mentioning there are a number of different sizes of hoist wells which are there for different manufacturers. I say we can travel the same distance in a very ordinary car or a very super luxurious car, and that's the difference, which is where the cost also comes into play, and the difficulty of choosing appropriate lift. Designers, especially architects, they want the interiors of the elevators to be very handsome looking kind of thing, which actually puts on the extra weights and by way of providing marble flooring, ceiling lights, and additional weights which go and which pushes up the weight and the cost. And various features have come in now. There is a destination control, there are biometric controls, there are access control, cameras, digital displays, which is they are fancy to have, but also expensive to have. And there are a lot of innovations which are happening, for high traffic flow areas. There are harmonized dispatching, one lift above another, as was just mentioned, and improved passenger interfaces offer improvements over both standard destination dispatching and hybrid systems, and serve as a platform for future performance improvements. Very high speed elevators, more than 8 meters per second. I personally have worked for provided one which was 6 meters per second. Destination dispatches, horizontal traveling, lifts are future. And we at Wadhwa definitely keep exploring new technologies and adopt them for our future projects. And with the help of consultants, which are must now, we get the insight and we try to follow the new norms. Thank you.
The next, I would like to call Mr. Rajnish Aggarwal again.
I started my career in the elevator industry in the early 90s. And I found, when I joined Otis, I found TAK there. And I knew that I was a couple of years late. And so I immediately shifted my profession. I could see no future ahead in beating TAK there. So going forward, Mr. Tendulkar, being the opening batsman here, also has taken up a few points which I had to make. So I'll be a little faster. Okay. So, what does a good elevator have to be? A good elevator has to be safe. The first thing first. Beyond all functionalities, beyond all aesthetics, beyond interiors, it has to be safe first. It has to have a built-in safety, which is by design, by default. And then it has to have add-on devices, whether it is a ARD, automatic rescue device, or it has seismic protection or whatever. Second, it has to be functional. It is very important that when we choose an elevator, we should choose it wisely. We have to see what is the number of passengers or the weight. Normally it always used to be 68 kgs per passenger on an average, which is a little difficult figure. They could have rounded off to 70 also, but 150 pounds has been converted. So, second is the size of the elevator or the weight it can carry if it is a freight, the speed of the elevator, and the efficiency. Efficiency can be the nominal travel time, it can be average waiting time, it can be so many parameters we can check before designing the elevator. Now, before I go any further, can I ask a small question? Is the lift or an elevator, are they the same? Our NBC part 8 subsection 5 starts with saying elevator and lift are synonyms to be used. Anybody can point a difference between an elevator or a lift? We invariably say lift lagana hai, elevator lagana hai, lift lagana hai, elevator lagana hai. Any? I won't ask TAK because I don't want to be beaten up again. So a lift can be open or closed. Elevator has to be closed. Lift can be used for lifting people or material. Elevator is essentially passenger. Lift can be, ancient. Elevator cannot be ancient. So going further, it has to be comfortable, of course. It has to be rich in aesthetics. It should have a good quality speaker for music. It should have good buttons. It should have a good COP. It should have probably now a LCD screen giving you the information about the weather or the building or what restaurant is serving what. So it can be more, aesthetic oriented or comfortable. The right quality. Does it start with a jerk or does it not start with a jerk? Does it level, which means when you come out, is the floor and the sill, are they in match with each other? How precise you want it to be? Do the doors make noise? What is the speed of the doors? So these are the next factors. So they come in this order. Then finally, again very important is it should be compliant to the rules and regulations of the industry or the bylaws. Now there are a couple of laws which definitely are thoughts of people who have written, which we will go into the panel discussion. We'll discuss that further. Now, how did it evolve? The actual elevator industry started when Mr. Otis designed the safety brake. The lifts were already invented, whether they were driven by traction motor or they were driven by people. But what he actually invented was the safety brake. By the way, does anybody know who was the inventor of the first elevator? Mr. Tendulkar definitely was correct when he said it was the third BC. But who was the guy? Archimedes, wonderful. The mathematician, Archimedes. He was the first person who invented the first lift. And it was probably pulled by animals or humans. And the kings used to probably travel up and down. Then came automatic doors. We've all seen those manual doors which we used to open and close. I don't know, the younger people might not have seen them, but we have been very used to it. And when somebody used to leave the door open, people used to, view from the top of the building and tell him to close it. Microprocessor controls. This is where the elevator started getting intelligent. They started having a brain. Till that time, they only had the functional parts. Sky lobbies. It is a very important thing which was put into the elevator design that people started to understand that it's not one lift or multiple lifts going up and down. You have to make zones in your building for different people to go up. Now, when we go to Burj Khalifa, we pay a certain amount of money to go up to 120th floor or something, and then if you have to go beyond that, you have to pay more. But that's one of the reasons is that the elevators have to be zoned. Now, any guesses? What could be the typical limit of the high rise which a single lift can cater? What is the maximum height a single elevator can cater? It's about 2000 feet, roughly 600 meters. So now we know that why taller buildings which can go up to 1 kilometer have different lift lobbies, why you have to shift lifts when you go up. One reason is that the gearless motors have a limit. Second, and the limit is because of the weight of the ropes. The weight of the ropes can be in tons, and that is the limit that sets. Then we had double deck elevators. I remember when I 1994 I went to Otis. For the first few months I was given safety shoes and helmet, and I was asked to travel on top of the lift up and down along with the technicians. And that is what probably became commercial, and people started having double deck elevators. So if the lift is anyway going up, if a few people are above standing on the ceiling and you make another cabin, they travel for almost free. In India, we of course have people traveling on top of buses and trains also. Destination control. This is another very functional aspect of lifts, where people, before getting into the lift, tell where they want to go, and the lift doesn't have a button inside. In Mumbai, we see it more often than in Delhi, and in other parts of the world, we see it more often. Here we have different reasons, but it's a very specific medicine to be given for a very specific reason. Destination control, mindlessly put, can be difficult. Though our NBC, very, very surprisingly, or I don't know, it was beyond my understanding, that NBC says that not more than 4 elevators will be in a row. Why not? Why? And if you have more than 4 elevators in a row, then you must have destination control. Now, the wordings are very important. The NBC says it is preferred not to have more than 4 elevators in a row, which means you can have more. But if you have more than 4 elevators next to each other, you must have a destination control. Why? If my building occupancy doesn't warrant a destination control, we will come to the... Yes. So it is a point to be discussed, and couple of architects we work with, they actually question us, or we tell them, and they are surprised. Then came the regenerative drives. The motors generate power back and feed it back to the system. So the energy producer motors came in, and these are getting more popular as we talk of green elevators. Green elevators are such elevators which have regenerative drives, which have variable frequency doors. Then the test of tallness, as the elevator industry stopped going further, then the architects, builders and town planners started challenging the elevator industry by making taller and taller buildings. So I hear that Dubai will have something taller than Burj Khalifa now, and Saudi will have something taller. And if the present government continues, probably India will have much taller than them in the coming time. Okay, now some few quick facts and figures. The first one is already answered. The first manual elevator was invented by Mr. Archimedes. Elevator speeds have gone up from 0.2 meters per second up to 10 meters per second functionally. Now, another question. Which speed is higher, going up or coming down by the rules, by the specifications? Going up because you have to reach faster, or coming down because you have to go home? Going up? Yes, because while coming down, you need to have more safeties in place. So you cannot, and secondly, by the gravity, you're going and the gravity is adding up, and you don't want to be suspended in the air. While going up, at least you'll be standing on the floor. So I would like to correct a small figure. America has 7 million elevators. Now, every year, the world buys 12 to 13 lakh new elevators. 12 to 13 lakh. And a couple of years ago, China was buying 60% of these elevators. And followed by India now. India is the second biggest consumer of the elevators today. And if India continues to grow, probably we'll see what happened in China will happen in India. So elevators become more important. Now, every elevator has multiple cables, and it's a very important, very good to know that even one of those cables or the ropes is designed to hold the entire elevator. Now, elevators carry almost 2.5 billion people every day, which is probably twice the India's population every day, or 1/3 of the world's population every day goes up and down. Elevators are pretty safe. Pretty safe. If you take 67 lakh trips in an elevator, there could be one trip which could be fatal. So 1 out of 67 lakhs, that is a probability. Pretty safe. It's probably safer than driving a car on the road. Probably safer than trains or airplanes. Now, green elevators I already said what it is. So, when this topic came that elevators or the lifeline of a tall building is an orphan, I was actually a little, amazed. I said, we have fatherly figures like TAK in India. How can the industry be orphan, or how can the elevators be orphan? So, I'll leave the rest to TAK to take over. Thank you, TAK.
Thank you very much. So, may I first invite the panelists one by one. Mr. Amar Tendulkar, Mr. Mukesh, Jaitely. Please get involved in the discussion. If somewhere along the line you disagree, please put up your hand and let's discuss it. We have the time. We are the last people, so there's nobody to chase us away from here. Anisha has promised me that we can have as much time as we want. Yeah, doctor is not left yet. Okay. So like I said, we have an architect, we have the project director, we have an MEP who's also an elevator person, and then we are pure elevators. So we'll sort of have a bridge between the whole thing. But before I get into it, a few clarifications. Destination control button. Why beyond 4 you need to have destination control? It is from the practicality of usage. You virtually will need to be PT Usha if you push the button and it's the last elevator that comes to you. Those of you who have been to Oberoi Towers, there are 5 elevators in a row. Despite being an elevator person, despite working for Otis at that time, I have missed elevators because the last elevator landed up. So that's the reason for DC button. The DCS. Door close button, it's a notion which used to exist that it doesn't operate. But in today's current situation, the door close button really does work. And particularly with destination control, you do need the door close button. Fastest elevator, right now the fastest is Hitachi's 20 meter per second elevator. But in the down direction, it is 10 meter per second. For many years now, Toshiba has had a 16.8 meter per second elevator that has been operational. But Hitachi today says that theirs is a Guinness Book of World Records elevator that is operational. But remember, going down, it is 10 meter per second. Okay, so let's get into the panel discussion. Like I said, we are going to be breaking it up into 6 different questions, addressing 3 parts. So when you look at elevators, the elevator lifeline, there is design. That's when the architects get involved and we sort of specify it and build it up. Then you have execution and then you have maintenance. You cannot compromise on any part of it because if you do compromise, there's going to be a problem subsequently. So we'll start with the first part, that is the design. The question that I'll be throwing up to Amar as an architect is, what is the basis for elevating of a building? What's the design basis?
The primary design basis of deciding on the number of elevators, type of elevators, speed of the elevators, locations of the elevator shafts in the building. It's from the the purpose of the convenience to the customers, convenient to the users. So that is the primary purpose. So what happens is when we start designing, as from the brief, what gets evolved is how many people are going to use this building, what is the gentry of the users, who are the resident users, who are the visitors, who are the service people. So those are multiple type of the users, and how those users are going to use the multiple type of the elevators or the elevators which are provided for that purpose. And then we put those elevators in such a way, uh, because see, the elevator shafts are the spine in terms of the structure for the building. So it's important that if you place the elevator and stairs core in the right way, so it supports the building doubly. One is for the vertical logistics, and second, it's from the as a spine of the building from the structure as well. So it helps in terms of optimization of the cost, making the structure more friendlier to the wind loads, seismic loads. Um, in terms of making the circulation between the floors as well as around the floor more efficient. Yeah, I think these are the few important things when we look at while putting the elevators into the design.
Yeah. Uh, Mukesh, you in your presentation you did talk about FSI. Um, what would be the overriding decision maker when it comes to elevators?
Definitely the convenience to the users, as Amar said, a lot of study goes into this, and when we plan out our building, we definitely, as a basic, look into the population which is going to be there, the number of elevators. Obviously, as I said, FSI is a thing which everybody would want to not to lose, but overriding factor would be the locations, the the kind of core we can have, a central core of elevators which effectively or eventually affects the structural takes care of the structural requirement of the building also. So if there is a chance where we can shift the elevator which gives a better core, better structural stability to the structure, we'll go for that. When I mentioned, let me distinguish between good developer and there are no bad developers, but those who don't put much study into the thing is like, we can have a 7 elevators all spread out and have a very structural design of the building which is not weak, but which is not efficient, which is not economical. And if I am putting a strong core where it's all bunched up, gives me many other advantage in terms of grouping the elevators, which eventually saves me the running cost of the elevators. There is a less wait time, there is a less travel time. All those things come into play, but nobody is going to lose a square feet of FSI.
Okay. Yeah, I think he's very diplomatically put across that nobody's going to lose FSI. One of the disadvantages that we have on this panel is that the architects here, the project person here, Dr. Ananya here, there are people who have probably been are on the better side of elevating, so that puts us in a little bit of a disadvantage. How I'll bring out my experience here, the FSI problem, and it's a serious problem. What ends up happening is you spread the elevators around the building to maximize your FSI. So you can have an elevator in the middle of nowhere, not because that's where the elevator needs to be, but because you can get the FSI free over there.
Yeah. So I have got an example. I don't want to name the building and name the developer, but there are few examples where you will see, the 70% of the living rooms were occupied because of the free of FSI lobbies, and 60% of the floor plate area comes out of the free FSI area, and that's how the 4 FSI or the 3 FSI multiplies up to about 14 to 15. So yes, those are the kind of advantages or disadvantages people have started taking
Okay.
of these rules and regulation. So, but in terms of the provisions of the elevators, I'm saying that I don't know. I mean, how do you take it? It has got nothing to do. It's an interpretation of the rules and regulation. I don't think it has to do anything with the quality of the elevators.
we'll come to the quality of elevators, because we start with the design. If you don't get the design right, we have a problem. Now, talking on the same FSI issue, another thing that we noticed is the hoistway sizing. We did talk about hoistway sizing here. So I've seen projects where instead of a 2.5 meter width hoistway, the hoistway is about 5 meters or 6 meters. These are existing buildings. So inside the 6 meter wide hoistway, you've got one piddly elevator. I mean, you put beams and all, and make the hoistway inside. Okay, no harm done, because at least you got the elevator size that you need. However, when the same thing becomes a deeper hoistway, you have one narrow stretcher elevator to maximize FSI. And I mean, it doesn't take too much for anybody to know that a narrow elevator is inefficient. You need a wider elevator to make it thing. So that's the problem with from an FSI perspective. Like I said, if anybody has an opposing view or a thing to add, please put up your hand and please jump into the discussion. Don't wait.
Into this point, I would also want to add, not efficient hoistway is also a cost. Eventually, developers also look into what goes into the cost of it. So, if it's going to be wider or a deeper hoistway, my extra supports for the elevators, is the additional cost which comes to us. But there is a math to it, and all those permutation combinations are worked out, and a call is taken on that.
Okay. The next question, and for that I would request you to take off your company hats off. Let's look at it from an all India perspective of the projects that you know. The question is, what percentage of buildings have elevating that is backed by a robust design basis and meets NBC requirements? I know you would not have done a research on it, but in your guesstimate, what percentage around the country, I mean, you've gone and weighted enough number of buildings in queues. When you look at it that it is not so what percentage do you think would be the number of elevators, buildings that are designed without any basis? Yeah, both of you.
Say about 40%, 60% are good.
60% are good. That's a good number.
To my
This is across the board, all India. I'm not talking about just, and let's not even talk about tall buildings. It's even small buildings.
I'll say about 50% of the building, at least.
50% of the buildings have some basis.
And no, if I had to say, I mean, between the A-class cities, B-class cities, so Mumbai, Pune kind of cities, I think the numbers will go to about 70%.
Across the board.
Yeah, I know, but I'm saying, I know, I'm coming to that, but I'm saying if you have to separate out A and B class, I think it should go beyond 70%. And then if you look at suburban areas and villages or the D-class towns or cities, I think then it will go to about 30% or something. Then it will average out to something 50.
Rajnish, your guesstimate?
Say 50% is a very safe bet, because you are equal to either ways. You can make a least error. But then I would say that NBC correlates part 8 elevators with part 4, which is fire. So it says for all the other fire aspects of elevator, please refer to part 4. Now part 4 in totality is on fire. And there are a number of things which as a MEP engineer I can see, because I have a taste of all spheres. When we design a building, our HVAC plays an important role in fire curtailment or smoke curtailment, and lift well pressurization, lift lobby pressurization go hand in hand to make a safe elevator or a safe vertical transportation or a safe building. So I would say that in totality, 100% adherence to NBC could be in the lower building, a low percentage of buildings. But I would say that I can very safely say that all the good buildings would be definitely closer to the NBC adherence.
So I'm not going to get into the percentage in terms of how many are good buildings. So let's leave it. By the way, clarification. Part 8 does not refer to part 4. Part 4 refers to part 8 as the requirements. However, in the entire process, I suddenly figured out there were a few clauses that were slipped into Part 4, which didn't have the Part 8 concurrence.
Yes.
When Part 8 we were putting it together, we had inputs from the fire authorities, Mr. Derry, for instance, and the idea was that there would be nothing that would need to be written in Part 4 regarding elevators. Unfortunately, between the cup and the lip, there was a few clauses that did get added on. Yes, sir.
आई थिंक हम लोग कंसर्न अथॉरिटी जो लिफ्ट का लाइसेंस लेते हैं और आई थिंक ऑल स्टेट में इंडिया में तो आई थिंक है ही है कोई ना कोई प्रोविजन इन पर्टिकुलरली इन बॉम्बे तो वो एनबीसी को मैच करता है ये हम नहीं बोल सकते
I'll try to.
क्यों लिसन मी अगर हम वो नहीं बोलेंगे तो अथॉरिटी गलत है या हम गलत है
Okay.
Is it I am designing also building also I am developer तो मैं बोल रहा हूँ कि कहाँ हम wrong है कहाँ
मैं बताता हूँ, मैं समझाता हूँ.
just asking
Yeah, no, I'll explain that. This is a question that comes up often. Maharashtra PWD, अभी Maharashtra Energy Ministry पता नहीं कि कौन handle कर रहा है inspection का. They do not look at the adequacy of number of elevators. उन लोग वो एक एलिवेटर आपने प्रोवाइड किया, उसका टेक्निकल स्पेसिफिकेशन मैच करते हैं विद IS 14665 और NBC का प्रोविजन. वो NBC का प्रोविजन जो जितना एलिवेटर चाहिए, that is not in their domain. So IS 14665 स्पेसिफिकेशन के हिसाब से it has to meet IS 14665. महाराष्ट्र में there's no doubt about it. एकदम क्लियर है. Okay, so if you go by IS 14665, Maharashtra you meet the requirements. Yes, sir.
You know, we are doing an affordable project in Panvel now. It falls under NANA and SIDCO. There, they definitely go with the criteria of number of elevators required. You know, these are the only bodies which insist certification from either from the lift manufacturer or consultant.
That's right. That's right.
Yeah.
Yeah, and you should have mentioned that.
Yeah,
That's right.
Yeah.
Just a quick point. If you see the oldest act, if I'm correct, act was the Mumbai Lift Act
1939.
1939, which came up. Later on, it was I think upgraded in 2016-17.
It has not been notified yet.
It has not been notified. So our NBC still says, please refer to Bombay Lift Act 1937 as the basis.
No, it's changed.
It is?
Okay. Now, एक और clarification. IS 14665 का कमिटी का चेयरमैन जो है इधर का चीफ लिफ्ट इंस्पेक्टर है महाराष्ट्र का. Unfortunately, we have not had a chief lift inspector for the last 10 months. So काफी amendments है, काफी standards है जिसका approval हुआ ही नहीं अभी तक. So we need a chief lift inspector to ensure all India का requirements are met. But Maharashtra, Tamil Nadu, in some cases Delhi, 100% accept करते हैं IS 14665 as a basic document. गुजरात थोड़ा सा changes किया है, बंगाल थोड़ा सा changes किया है, but otherwise they are accepting it.
Secondly, I work in many states. So for the first time, I came across a project I was doing in Hyderabad. So very safely our developers, when they place the order of the lift, they very silently lift in the right in the contract of the vendor. Lift ka license lena is aapka zimmewari. That is the safest. They try to push.
Just a clarification, Hyderabad doesn't have it. Let me just get into the next.
That's what I said.
Yeah.
Hyderabad, to my surprise, doesn't have a lift inspector.
Yeah.
None of the lifts are being inspected in Hyderabad by a lift inspector. And moreover, even in Mumbai, even in Delhi, the number of lift inspectors versus the population is very, very skewed.
Please, want to take a judge in terms of my question? What percentage?
I mean, what all areas you cover, it depends on that. Basically,
Percentage, just throw a percentage. We are not going to dispute you on that. We varied from 70% to 30% to 50% to no percent.
no, what I mean is, if you
Just give a number.
okay, maybe 60.
Are designed well.
No,
Okay. Are not designed well. Okay. The fact of the matter is we do have an issue. Yes, sir. Double digit number, you're surprised. Okay. If I were to ask myself, I put this way, that if you go to a building and ask them for a design brief of the elevators, 90% of the buildings, I'm repeating 90%, and I've done a survey, they will not have a document to prove it. Why they've selected the elevators they have. And out of the 10% that have a document, we keep reviewing reports, many of them not even worth looking at. We are going through a building at the moment. This is a foreign consultant who has given the document, and he's got a figure of 10. And we have been trying to figure out how he got the 10. So whether it was 100 divided by 10 or it was 8 plus 2, we are going through that back calculation. So we do have a problem. And probability wise, sometimes things fall into place. Now we'll jump into it because we're going a little behind schedule. We'll jump into the next question. What's the primary driver for procurement decisions? I would start with as a project director. What is the primary driver for procurement decisions? I'm not talking about Wadhwa. I'm talking about.
Yeah, generally, if you go to see the cost or the pricing of an elevator would definitely drive that. But as in the beginning you said, there are developers and there are developers, so it would make a difference from that angle. But primarily, in my career, I have seen the brands are the favorite of the particular season. One season you'll have X brand doing quite well, and another couple 4-5 years down the line you'll have another brand quite doing well. So it's more of a herd mentality with the developers which works. And having said that, the pricing is the key criteria for sure. And with the developers who definitely go into this as a Wadhwa or working with different developers over the years, at that particular time, what is the current technology certain companies offering, the benefits have to be looked into, and that would be more prudent to select the elevator.
So at this stage, there's a question which I can't avoid. I can't avoid not asking. I don't want an answer. So we've decided already that design is crucial, that we need to get inputs to design. We agreed on it. We're talking about money also. How much does an elevator consultant get paid on a project? And vis-a-vis a landscape consultant, for matter. I don't want that answer, but a food for thought. I'm talking as a consultant and I see these through projects. It's a food for thought, going back to our original criteria. Now, there is a concern that we have about, design being, procurement being, driven by costs and things like that. This country is moving in a big way towards affordable housing. And a question that worries me a lot is for real premium building segments, we drive down on costs. I sit on the other side of the table and negotiate with elevator companies to get a good cost. What's going to happen when the affordable housing comes up? What more are we going to do to drive down costs? And that is a matter of serious concern. And I'm not going to throw it to you as a question. If you remember the Indore accident that took place, 6 people died. They were not from the lower strata. You're aware of it, right? December 31st, 6 people died in what I would refer to as a contraption, which was masquerading as a lift. Now, those people, they could have afforded a good, solid, safe lift. But they went with a cheap contraption, which was on a temporary basis because it had to be disposed of. Net result, 6 people are dead. And this worries me a lot as to what is going to happen when we shift in a big way towards affordable housing. And this is something that I keep putting up often. I've done this often. I think most of you would have already seen it also, where there's always somebody who can come up with a cheaper solution. But that cheaper solution might not be the right solution. Okay, I'll send it to you later. Okay, so now let's get into the next part of what we were talking about in terms of execution. Okay, and I'll start with Tipness. How does the industry, the client base, the developer base, approach elevators during execution? If you would just hurry it up. You had these questions earlier itself, so you should have the answers ready, right?
No, from if you really consider the conditions at site, less said is better probably. If we leave out the top few percentage of the developers and builders. Generally, the conditions are so pathetic that at the end of the thing, when your elevator is ready for use, I think its half life is already over. So that's the condition in which the sites are managed. In short, that's what it is in erection.
Uh, Mukesh, anything to add on to that?
Yeah, for sure, I agree with Mr. Dipnis that by the time elevators actually come into play and there is a maximum utilization happening, things start going wrong. But about 2 days back, I was discussing the same thing, and this is most common with the electronic parts which are used in the elevators. Now, what happens? Typically, an elevator company, when the order is placed, they back place their order to the parent company and they import the stuff and everything. And I think some inventory management is required on their side when a certain components have to arrive. When there are two things: A, the electronics go wrong; B, they said the elevator company starts asking for extra money because a certain warranty or the guarantee of that product is over. Now, which is not a developer's fault. I will count my day one when I get a PWD certificate or it is handed over to me. In between, any component going wrong is it is something like I go and buy a car and it was parked in a yard and suddenly it rained and the seats are wet. I am not going to take that car as a delivery as a fresh car. So certain inventory management on the OEM side is also required.
What I'm going to do is put across some pictures which are just representatives. These are the conditions in which elevators are installed at site, and these are just random pictures. It doesn't matter which project site it is. So you talked about electronics. So what you see on your thing are rails which are submerged in water. Okay, and these rails, once installed, probably will outlast the life of the building. On the top behind is again water going into it. Once the elevators are complete, they get used as freight elevators. And what you see at the bottom is the worst situation, because bottom right, what you see is slurry in the door sills. And this problem is going to be there for the life of the building. Because once you've got the sills, which are supposed to be where the doors are supposed to be opening and closing, you have a problem here. Now, when we talk about a tall building, construction lifts are important, are required. And there are solutions for it. But of course, there's a cost. You have jump lifts, you've got temporary construction lifts. But what we end up doing is we try to use the same lifts to save on costs. Now, try to visualize a construction site and where toilets are getting handed over. The way they are locked and kept carefully vis-a-vis something which is the lifeline of the building. And I must say this, if I were to ask in terms of percentage, it's probably 90% of the buildings. Again, we have a group of people who are on the panel who probably fall into the 10%, so it's getting a little difficult to put it across, but that's the reality across the board. Okay, I'll jump into the last question where Rajnish and Tipnis, if you could do. What happens during maintenance?
Okay. Very predictable. We all wait for our arteries to be blocked before we get health conscious. That is the same way we treat all our machinery. अभी तो लिफ्ट नया है, अभी AMC देने का क्या मतलब है? अभी तो बिल्कुल ब्रांड न्यू कार है, अभी उसका सर्विस के ऊपर पैसा क्यों देंगे? So let us drag it a bit. We don't understand that we have to start eating healthy, start living healthy when we are born. So a machine which is kept healthy from the beginning stays healthy for a long time. It is very surprising. I have seen the worst of this because I was a modernizing engineer in Otis. So I used to be handed over the old lifts which were to be modernized. So I've seen the condition of the lifts. अगर 4 elevators है, तो धीरे-धीरे AMC नहीं देंगे, and then slowly they will keep moving parts, shuffling from one to other, till the time all of them become dysfunctional, and then they will try to find a local guy to set it right. And when finally it doesn't work out, then they will probably call the OEM. But the other way is that yes, I have heard allegations saying that lift companies do overcharge it if they get an opportunity. These are allegations we put on doctors also. We put on, so it is subjective. All doctors are not bad, all lift companies are not bad. But I would say that as a consultant, we probably try to advise our clients to put at least a 10-year maintenance along with a contract with all spares and consumables, so that at least you have the rates negotiated and tomorrow you don't feel that you have been charged higher. But of course, lift is as essential as an aircraft. I always give that example. I am a BMS engineer also, so it is always the IO points which are crucial. In an aircraft, there are 10,000 IO points, whereas in a building which is probably costing the same and has the same life, probably will not even have 1,000. So the difference is that how critical it is. I see lifts as critical as aircrafts. So I would say that maintenance is of utmost importance. It has to be put into the drilled in. Last point before I close, because we are running late.
Yeah.
I work with so many clients. I feel pained when recently one of my clients told me we have shifted from bigger elevator companies to smaller elevator company because bigger elevators company do not cooperate. I said, how they don't cooperate? They said, no, when we have to open our building, they insist on getting the certificate first. And chota vendor jo hai, he will normally listen to us and on the day of opening, he will operate the lift. So this speaks.
Tipnis, we could give your thought process quick. We are really off.
I think the slide that you showed shows a lot of things, and we really did not talk about it because the earlier ones, which showed several incidences that happened in 2019. So there are so many accidents and casualties that are happening during the service stage of the elevators, which speaks a lot of volumes about the maintenance quality and the parts that are used. So these are really serious issues, and we have to really look into a wider perspective as to how the genuine parts would be available across.
So my comment was on usage and maintenance, and I'm going to just sort of jump you on that. If you look at the photographs, extreme top left, you know what those colorful stuff is? Yes? It's pan. So if you go to any elevator, except probably a 5-star hotel, and you look between the doors, this is what you will find. Now what happens? What does pan do to steel? What does pan do to contacts? Okay. The picture that you see at the bottom is an operational elevator. The client was complaining, oh, the lift is not working. And if you look at it, it's a block of concrete that has fallen on the door operator. And they expect the lift to be functioning. Unfortunately, I can't get this running. This is a brand new set of elevators that were handed over. And there are, I think, 3 elevators in this thing, and there's water falling on it. All the machines across the thing, there's water falling on it. So we come back to the final thing about the point. We do have a genuine problem. I'm sorry that I did sort of try to push it across. And unfortunately, I think we should have picked up a few developers who are probably from the 40 or the 30 or the percentages to get this discussion a little bit more. So the gentlemen over here had a little problem taking their hats off. They would always keep referring back to it. But thanks a lot for this panel discussion. But before I close, any questions? Anything that you would like to ask? Any point that you would like to stress? Any disagreement? Yes, sir. Mock drills. Okay. It's all important. These are things that require to be done. Unfortunately, we are not doing as much as it, because at the moment, everybody, whether it is the industry, whether it's a developer, we are all busy doing business. But these are crucial issues. For instance, I run a trust called the Elevator Escalator Safety Trust, which is focused on teaching children how to use elevators and escalators safely. So in those accidents, the 2 of the accidents, definitely because the person didn't know what to do with them. So these are critical issues, but I don't think we can address it here. Anisha will throw me out if I don't have it there. If there's nothing more, we will close this panel discussion. Amar, thanks a lot. Mukesh, thanks a lot. Rajnish, thanks a lot. Tipnis, thanks a lot. Thank you very much for your input.